Hello and welcome to the C++11 Beginner Tutorials by Gamer2Creator. I'm Chris. So we're going to continue our discussion of the STL. Now we're going to cover streams. We've been using some streams. We've been using cout and then some variable to count, which is 2 would be an int, and then a new line. Now I want to point out that this is also a new line. The difference here, though, is if we go to the definition of this, we can see that it's actually a couple of function calls. It's putting a new line on a stream, but it's also flushing the buffer. Now, I'm not going to get into detail what flushing the buffer means, but it means it's doing extra work. So this gets the job done. Now what we're going to do is we're going to cover an out stream, where we can take some data that's in our program and send it out to a file. Now because whenever you run a program, all of your memory or variables and data is in memory. Whenever you close your program, all that memory is freed and your data no longer exists. So if you want to keep your data, you need to save it to the hard drive. So we're going to make a vector of employees, maybe just 2 or 3 of them for an example. You can have however many you want. And then we're going to use an out file stream to output to the file. So let's get started. Now we have our vector here of employees. It's the template argument is employee. And we saw this in the last video. Now we need to include ofstream. Found include ofstream. This, like iostream, includes our stream classes for file input instead of just console input. Now what you're going to find is that file streams, when working with text, is very similar to using the console streams with text. So let's fill our employees vector with some information. Let's do employee. So here we're going to get 2 employees from the console. And push them onto the vector. Now we could do a loop that would create our employees for each iteration, but since we only have 2, I'm going to do it this way. It's a little more straightforward. Alright, so we have our employee data, which we will have gotten from the console by the time we get down here. So it's time to make our out file stream. Now the class name is ofstream. We're going to call our variable ofs for out file stream. And as you can see, this turned blue because this is actually a class name. Now because we're using the namespace std, we don't have to use the fully qualified name. However, you can if you wish. As you can see here, that is pink because that is a namespace. And it'll only be pink. These colors will only show up, at least most of them, if you used my settings file. So now we have 2 options here for opening the file that we wish to output to. You can call your file anything you want, with any extension that you want, as long as you know how to read that file. So we're using the constructor here to open our file. We've given it the file name and some open mode flags. Now, these flags are used to tell your class what mode to be in when it opens the file. There are some other ones that you may be interested in. iOS binary. This will open it as a binary stream, but that means that the code will look a lot different. There is also iOS in, which you would use for an input file stream. We're using an out in this example, so we'll leave that. And what this is the OR. What it does is it can combine the left and right values on each side of this OR into a single value. It does that using bitwise operators. We're not going to cover those just yet, but just know that you can combine values using the OR operator. Now another one that might be of interest to you in the future is ATE, at end. This will set the initial position to the end of the file, so that means at end. One more that you might be interested in is app. This means append. So if you wanted to open up a file and just add more data to the end of the file, you would use app as one of your open modes. If you don't use anything but out or in, it will automatically be a text stream, and it's going to delete everything in your file when you open it, and then start fresh and start writing new to the file. So the other option that we have for opening is ofs.open. As you can see, I didn't even have to rewrite the parameter list because they are exactly the same. The file name and the open modes. This is how you close a file. Now, because we have the option of opening it either using the method or the constructor, we also actually have an option of using the close method or the destructor. Now if we were going to wait for the destructor to do the closing instead of using the method, it would wait until this object is destructed at the end of this function. So it would happen down here. But sometimes you want to just say, okay, close it right now, and you would do that because every time you open a file, you lock that file. The operating system gives you access to this file, but locks it from anyone else being able to manage it. So if you have code in the same function that opens the file, writes to it, and then closes it, and then opens it again, maybe to write to the file again, you would need to close it, as I suggested. But if you don't, you may run into errors. So it's good practice to just go ahead and use open and close. Now, after you use open, you're going to want to do a check to make sure everything went okay. And you can do this using ofs.good. This is just a method that happens to return a bool to tell you whether or not the stream is good. If the stream is good, then we have opened the file and there were no problems. So we can begin to output. So we're going to do a loop. And since we used myEmployees.size, we're going to loop for each employee. And we're going to, almost the same as counting this information to the console using the cout stream, we're going to use the OFS stream. to output our data, and we're going to use the new line character. So every time we put a variable in here, it's going to convert it to a string. The same thing that cout does. And then we push a character on to denote a new line. This is our delimiter. This is what separates our data from each other. Otherwise, the first and the last name would be smushed together and you wouldn't be able to differentiate the two. And there we go. We've written one employee to the file. The first, last, age, and salary. Each one is separated by a new line. We've done this for each employee using a loop. Down here, we've closed the file. And this will be the end of the file. And the end of the application. So when we run this, it's going to ask us to input these two employees from console. Now I've put a breakpoint right here. This line has not executed just yet. It will be the next one to execute. I just wanted to point out that imp and imp2 have been pushed onto the vector, and this is a copy. Okay? So now, when we look at our file that we just wrote, we can see that everything is exactly how I entered it. This is the console input, and this is the file. So whenever we close our application, everything we put into the console will be lost unless we put it onto a hard disk file. If you put something on the hard drive, it will stay and then can be loaded up later. Now one more thing I want to show you is that this code is actually valid if you put a count in here. It doesn't do what we initially wanted it to do, but as you can see, this is actually valid syntax, and this is how we have been using cout. And OFS is very similar, and in fact the same code works with it. So you should feel right at home, and just remember that this used to be an end line, and this is technically doing the exact same thing. And from now on, we will probably use this when we're using cout. Now there are a few other things that you should know about streams. First, there are some methods for checking flags. We've used one, ofs.good, but there's also, and I'll just put them down here, ofs.fail, ofs.bad, and ofs.eof, which means end of file. This is how you can check for 3 different things: fail, bad, and end of file. And we also have good up here. Now if you wanted to reset your stream, like for example you had some kind of problem and there was a bad but you know how to recover from it, you can use ofs.clear and this will clear the flags that were set. Now making your buffer work again is up to you. But it's important that you understand this is how you check for particular errors. Now bad and fail are very similar, but they do have slightly different meanings. And if you wanted to see those, you can check the documentation. So I think this has been a pretty good introduction to output file streams. As you can see, they are very similar to Count, because they are all part of the STL and they all inherit from some sort of stream. So their interfaces are very similar. And one thing I want to stress is that I use these new lines because I had made the choice that I'm going to delimit my data using a new line, and that is why when we open the file, they're all on a new line and it's really easy to read. So doing it like this means easy to read and easy to parse. However, if you wanted to come up with a different system, that's up to you, and you can do it.